Good morning. Uh, several procedures can be used to calculate the thickness of proposed asphalt pavements. All are based on the volume and weight of the traffic that will use the facility on the load, supporting the capability of the underlying soil. In this report, we are going to tackle the thickness of pavement as one of the factors that is very significant in the calculation and the design of the pavements. I am Muhammad Isaim Alawi and this is the report on the structural design of pavement thickness. Here is the outline of the report. We will firstly introduce the pavement of thickness design. Then we will briefly get on a discussion of the types of flexible and rigid pavements. One of the basic requirements of pavements is that it should be of a sufficient thickness to spread the surface loading to a pressure intensity that is underlying on the subgrade and also is able to stand with the pavement itself sufficiently robust to deal with the stresses incident on it where required. The pavement should be sufficiently thick to prevent damage to a frost stable subgrade. Thickness is thus a central factor in the pavement design process. In the design of pavement thickness, we focus on the necessity of taking into a consideration the sufficiency of the material that is supposed to be included in the mix of the pavement. Thickness is very important because it deals with its proportionally to the strength of the pavement itself. The design of the flexible pavement has its types. General, the road note 29, the LR1132, and the HD 26/1. First, first off, we have flexible pavement. Pavement are called either flexible or rigid according to their relative flexural stiffness. Flexible pavements have base courses of broken stone pieces either compacted into place in the style of macadam or glued together with bitumen to form the asphalt. In order to maintain the workability, the stones are usually less than 1.5 inches and in size and often less than 1 inch. The pavement should neither too thick nor too thin. It is it If it is too thick, the cost will become excessive. And if it is too thin, it will fail to protect the underlying unbound layers, causing the rotting formation level. Flexible pavement is defined as one where the surface course, blinder coursing based on materials are bitumen bound. Permitted the materials include hot rolled asphalt or the HRA, high density macadam known as HDM, dense bitumen macadam known as DBM, and dense bitumen macadam with 50 penetration bitumen known as DBM 50. And the next of we have the road 29 R road 99 or RN 29. Road note number 29 was published originally in 1960, and the first major revision was issued in 1965. As recently as 198, the recommendation for the unreinforced concrete pavement were reviewed by a panel of the Road Research Laboratory Research Committee on a concrete and as an interim measure to prior to a further complete revision of the road note. These were issued by this was issued by RRL report or LR 192.1. The need to mitigate has provided an opportunity to bring the road note up to the date to reconsider the business layout originally adapted. Road Note 29 takes account of increasing axle loads and vehicle numbers while also differentiating between the characteristics of the different road-based materials. The road base is assumed to satisfy the entire strength requirements for the entire pavement, with the surfacing considered to make no significant contribution to the strength of pavement. The primary function of the surface material is to provide a surface texture and regularity. Road 29 was the sole officially recognized pavement design methodology throughout in the 1970s and early 80s. While it was considered to be generally effective, it had a certain inherent deficiencies. It was seen as unresponsive both to improvements in the quality of available raw materials and to changes the in the construction processes. The RN29 method is uh, valid for designs up to 40 MSA. The 20 years design life implied that after this period, a surface rot of 20 millimeter or more or severe cracking or creasing had developed. LR1132 revised RN29 by defining the pavement failure, thereby delivering a thicker but longer lasting highway likely to be in a less dis, disoriented state after 20 years. In contrast with the RN29, where the failure condition was presented as a 20 millimeter rot with severe cracking, egg raising LR1132 defined the end of pavement design life as indicated by a 10 millimeter rot dip that that or the beginning of crackings in the wheel paths. These least severe indication were chosen on the basis that they are the precursors of significant structural deterioration. We can see in this figure that pavement is affected by the moving load towards 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 on it. There are factors that affect this process, and this system of the moving load pavement relationship This is mostly in the case of buti, bituminous layer. Uh, LR1132 approach to maximize the use of existing pavement strength. A pavement more uniform strength will result. In addition, as a deterioration can be predicted without too much difficulty, and ultimate reconstruction can be more easily planned. The definition of design life result in LR1132. This designing a pavement having an additional period of serviceable life before major reconstruction. A period that will not available if the road note 29 were used. A design life of 20 years is normally employed. The design pavement via the LR1132 is here is the steps. Calculate the total number of commercial vehicles using the slow lane over the N years design life. Calculate the damage factors. D. In order to convert TN into equivalent standard axles, it must be multiplied by the vehicle damage factors. Damage factors D. Calculate for the mid-year of the design FM. Here, here is the equation of the calculation of the damage factor. The figure the figure shows the design curve for highways with bituminous road base. We see the subgrade CBR to be about 5% with thickness of 225 mm and with a probability of survival of 85%. Figure number 2 shows that the design curve for highways with mixed road base. We see two curved lines in this graph for the road base and the surfacing. Just like in the highways with bituminous road base, we see the subgrade CBR to be about 5% with the thickness of 225 millimeter and with probability survival of also 85%. And lastly, in figure number 3 shows that the design curve for highways with lean concrete road base. The last figure exhibit of the pavement composition for traffic levels greater than 80 MSA. This shows that the general composition of bituminous pavements designed to carry a traffic in excess of 80 MSA. The total thickness of the bound layer should be approximately 400 mm for cumulative traffic in the range of 100 MSA. In this part of the report, we will discuss the rigid pavements, which consist of jointed concrete pavements, the URC and the GRC, and continuously reinforced concrete pavement known as the CRCP. Rigid pavements. The Transport Research Laboratory publication RR 87, known as the Matthews and Harding 1987, is like LR 1132, empirically based, taking count of full scale concrete road experiments. The and the, docu- the documents concretes on the performance data for jointed unreinforced concrete, known as URC, and a jointed reinforced concrete, the GRC. The sites evaluated had service lives of up to 30 years, were subject to be a traffic loading over 30 million standard axles. And Matthew Harding derived the two questions. Is each estimating paving life based on a set of independent variables? In the joint concrete pavement in URC and GRC, the Transport Research Laboratory publication RR87 is likely LR1132, empirically based, taking account of full-scale concrete road experiment. The document concretes on the performance data jointed and reinforced URL. Uh, Continuously reinforced concrete pavement is one in which the reinforcement is at a sufficiently high level that the slab can withstand the incident stresses without requiring the use of transverse joints. The slab type will require less maintenance than a jointed pavement and will span more effectively over areas where the underlying soil is weak. A, a CRCP ensures that a uniformly high stress level is maintained with the slab, and that is the fundamental pavement thickness design. And thank you for listening.